Every function that we've worked with this semester and that you've seen in previous classes has certain rules and properties that govern what we can do with that function, things we can't do with that function. We want to start introducing those for logarithmic functions so that we can build our way up to evaluating logarithmic statements, and then in a later section move on to solving equations involving logarithms. The first property that we want to introduce is that the log base b of 1, so regardless of what our base is, will always be equal to 0. And that's going to be true because we can always rewrite a log equation as an exponential by taking our base and raising it to the power on that other side. So we could rewrite this expression as b to the 0 power. Anything raised to the 0 power is equal to 1, and that's how we know that this property is true. We also know that the log base b of b will always be equal to 1. Using the same trick, we'll rewrite this as an exponential function. So this will become b to the first power, because we'll take that base and raise it to the exponent on the other side. Anything to the first power is just that same value, so we get b. Since b to the first power is equal to b, we know that the log base b of b is going to be equal to 1. We also have a product rule for logarithms, which tells us that if we're taking the log base b of the product of two expressions, m times n, we can expand this out or rewrite it as the log base b of m plus the log base b of n. So when we have multiplication happening inside of a logarithm, we can expand that out by taking the log of those individual factors and adding those results together. The quotient rule for logarithms tells us that if we're taking the quotient of two expressions, or we're dividing two expressions, then we can again expand this out by taking the log base b of each of those individual expressions, but instead of adding them together, we'll subtract. It's important that we keep those two properties straight. Multiplication, when we expand that out, becomes addition, and division, when we expand this out, becomes subtraction. And the last property that we want to introduce is called the power rule for logarithms. It tells us that the log base b of some expression m raised to the n power, let's make that a lowercase n, is going to be equal to n times the log base b of m. What happened here is that that exponent that m was being raised to just gets dropped down as a factor in front. These properties can seem strange, especially at first, and if you're not used to working with logarithms, but through the next several examples, we'll take a look at how we can use these properties to rearrange logarithmic statements and eventually move into evaluating logarithmic statements.